what are agents, right? So uh, normally your LLM doesn't have any hands or legs. LLM is good at thinking stuff. It's good at creating poems. It's good at writing you that email that you have been procrastinating for. However, if you go and tell the agent that, hey, go and send me an email, it will say, I don't know how to send the emails. And for that reason, you need to provide agent tools, right? And these tools can be of various types. Some can be like just email sending. You can trigger another workflow from it, or it can also go to a RAG kind of a system where you can use your agent to do knowledge retrieval. So, like, let's say you have a customer support agent or IT help desk agent, right? They can access your internal documentation. They can figure out the relevant information, do a couple of other tasks, and give you a consolidated answer, right? So agent has multi-layer approach. It can also plan stuff for you. So if you give it an overarching task saying that, hey, tell me about my laptop refresher coming up. So it can go up, search your details. It can figure out who you are, when your laptop's due. Then it can even go to the inventory and say, hey, there's a new laptop available, and this is the link to apply for a new laptop. So it's kind of planning the steps as well as not just thinking and planning, it's doing the steps for you. So that's agent for you, right? And now coming to AWS Bedrock, the concept remains the same, right? You have an agent. An agent will have a LLM associated with it. Along with LLM, the agent will also have some instructions which are like the system level instruction, like where we assign it a role saying you're a helpful agent and don't go rogue or don't be rude to the customer, right? Something like that. And then you have prompt store. Now, not every so this is very AWS Bedrock related, but I want to keep it very high level as well for like generic agents. So these are like prompt templates, right? So along with these system prompts, you can also add other instructions to it, like how you have what kind of constraints it can have, what are like few short examples how that agent can work, right? So in addition to like basic system prompts, you can also add some advanced information to it. And AWS has this concept of a prompt store, which we saw, I think, in the first session, where you can try out different prompts in AWS's Bedrock Playground, save those prompts, and can use them in different of your applications like agents or flows, right? So that's the prompt store. Now when an agent has to do some operation, it has a concept of an action group and knowledge base, right? But let's call these together as tools. So tools can be either of action group type or of knowledge bases type. Action group type is your classical, right? Think, want to do something, here's a function to do it. Go at the back end, it will do the job for you, return a response back to the agent, and agent will show that to user or use that to do something else, right? And knowledge base is your classical RAG system. So we saw this RAG system in the session 2, where we had some data sheets at the back end, and we kind of created a knowledge base out of that and asked it some information, right? So let's say I have a use case where I want to provide user with a license, right? Let's say I have a software product, I need to provide him with a license for that software product. So, and my agent does all the orchestration for me. So I will just say, hey, my user XYZ needs to run feature ABC, right? So it will first go to knowledge base and figure out that, oh, feature ABC corresponds to license element. It will take that license element and then go to the email kind of functionality that I have coded in my action group Lambda. In my Lambda, I have programmed it to send emails. It will take this license XYZ that have retrieved for feature element, and it will send that license XYZ based on the user ID that is accessing this agent. And that's how the whole thinking and actually doing the email sending action takes place. This is how an agent kind of architecture will look like in AWS Bedrock. You can see the same building blocks here, but there is a pre-processing and post-processing as well. So you can, before even the information hits the agent, you can do some pre-processing. Let's say I work for Apple and I don't want my customers asking information about Windows. So in my pre-processing itself, I can put these conditions that if, well, if the user is trying to ask for a competitor, don't even bother querying the LLM, right? Because every LLM call is a cost associated. So I can do some pre-processing. This is also good for putting some guardrails about, like, if someone's being rude, if someone's trying to harass the agent, then just don't go ahead and respond to, just drop the conversation there. You also have post-processing for use cases where I am processing something like credit card information, right? So if the agent comes back and saying like, hey, this is your orchestration key, please go and uh, put it in your software licensing wizard, right? I'm not sure if I want to expose that in my logs, right? Because if tomorrow someone gets my logs, they can easily access my keys, right? So credit card numbers, your license keys, your quote values. So I work in pre-sales. So in pre-sales, it's very critical to quote right numbers, right? So you don't want your competitors or your numbers to get out in the public to show like how much discounting you're doing, or what are your terms of engagement with the customer. So those kind of information you can hide it in the post-processing. Now today, along with this, I will also show you a simple Lambda agent that I have built, right? So let's first go to here in agents, right? So in agents, I have created a player selection agent, right? So now the goal of this agent is I'm going to provide a tournament, like one of the four Grand Slams to this agent. And based on the tournament I provide, the agent is just going to return me a player from that who might be good for that tournament, right? So if you see how I've constructed this agent is in so here is, I selected a model, which is the LLM, which I just showed you, right? I selected the role, and then in the instructions, I gave it a very simple instruction. You can make it as complicated as you want. So I said that select a tennis player based on tournament and answer like Samuel L. Jackson, because I just like the way he talks. So I just gave it a role and gave it a tone of how it should respond. And then in the action groups, as you can see, I have created a action group here. Now, if I click this action group, there are two options. One is Lambda and one is OpenAP. You can create a Lambda function yourself, and other is you can provide an API schema to it. So there are two ways in which your AWS Bedrock will send these events to your backend, right? In both the cases, we write the logic in Lambda, but the way the event is structured is different for when you send to a API schema based backend and a API schema based backend in Lambda, and a regular event parser backend in Lambda. So here you can see I have created a new Lambda function. This is the name of my new Lambda function, right? And if you go to the bottom, you can see uh, that I have set up to tournament parameter, right? So what my LLM does is when a user asks a question, it figures out, it parses that intent from the user and figures out, hey, what tournament is he talking about, right? From a blurb of text that I'm providing it, it figures out a tournament, takes that tournament from it, creates a event like how you can see here, right? It will create a JSON event here, take the parameters that have been provided. So in my case, the parameter name is tournament and the value will be whatever it will parse out of my intent. It will take this value parameter and pass to my backend for parsing. Then it comes to my Lambda function here at the backend, right? And from that whole JSON, now I'm so just hang on. And from all that JSONs, I am now parsing out different things like action group function. You can do whatever you want with these things in this logic, right? But main thing that we want is the parameters. So in the parameters here, if you see, I'm also logging them. So the parameters come in this format, right? So ideally, I would have written a little bit more complicated logic to say that if the name is tournament, they only get the value. But for our demo purposes, I said that, okay, the parameters zeroth element in this particular list I want to get the value of it. So that's what I'm doing here. I go to the like the first element in the parameters. I get the value of it because there can be multiple parameters, right? But in my case, there's only one parameter. So I just select the first one and get the value. And then this is a very normal logic, right? I have a dictionary of players. I say, okay, get me the, based on what tournament user has entered, I'll get the value of what player the my tool is suggesting me, right? Now again, I can make this a little more complicated because here I'm not doing lowercase, uppercase. I need to match the case, but the goal is not to write the backend code, is to show you how the whole ecosystem works. And the uh, way the Lambda function has to be written is you need to be careful because you need to pass these parameters first, right? And when you return this response, right, it should be in this particular format itself. Like there should be a response body, this text. There are multiple types of responses, but this text, right, this is like case sensitive, right? It's a kind of keyword. You need to put this text and then body, and then you can have this whatever you want inside the body. But the keys of this particular or this JSON format needs to be followed, right? And then this is how the response goes back to your AWS Bedrock, right? So in the response, it's kind of aggregating your response and the message version. And uh, if you don't follow this JSON, your AWS Bedrock will not recognize that this is a response given to my request, right? So this response, there's kind of a good pairing between what request you sent and how the response should look like. Now let's go back and test it out quickly, right? So if this was my agent, right? So let me go here. I've already go to player selection. I already have a version of that player selected here. So I just test it. Yeah, so get me a player for US Open. So it got the player, probably it got the player faster, but then it's taking some time to frame it like how Samuel Jackson would say. And then it's like like Serena Williams is the queen of the court. And you know that this response is coming from Lambda because in Lambda, we have for US Open, Serena Williams is the player, right? No matter how many number of times you try, it will always give you Serena Williams as a player. Now, if you see the trace, here is what I've been showing so far, right? Like the pre-processing. I don't have any pre-processing put in. You have, but this is like orchestration phase. Like so, in the trace one, you can read all of this, and this was the system prompt that we put in, right? Selects a tennis player, and then it figures out how to route this message, right? The user's goal is to get tennis player associated with user tournament. Here is where it's trying to get the intent of the user. And it says that, okay, no steps completed, need to start by calling the API with provided tournament available action. So see, it went to the action group. It knew that I have to call this particular action group to get the tournament play because I have put like a description on that action group, right? What it does. And yeah, then it sent this US Open as a parameter in this tournament, if you see this, right? And uh, yeah, and then it went back in Lambda, it called this function tournament player, and then it got an output, right? So see, the function was successfully called tournament US Open player Serena Williams. That response came back to LLM. LLM then figured out, hey, my tone should be like Samuel Jackson. So let me take this output and frame it in the way user has asked me to. So that's how you can have Lambda as your backend, right? And with Lambda, you can do anything, right? You can have Lambda as like your MCP client. You can call different MCP servers at the backend. Call you can send emails, you can run backend jobs, or if you have like an, let's say, n8n workflow, you can create a webhook there and you can trigger it from your Lambda function. So based on what user asks, you can have this sub workflows, right? So n8n can be a workflow which is now triggered from a bigger workflow which is in AWS Bedrock. So you can have multiple use cases like this, right? So coming back to our agent, right? So like we had our Lambda function as the backend agent, you can also have a knowledge base added in as an agent, right? So as the use case that I told before, right? You had action group, and if you go at the bottom, you have this memory which will remember your conversations, right? So if you are in this chat window and talking to the agent, you know that it will know that, okay, you asked this question at the start and what response it had given. But now if you want to attach a knowledge base as a tool, you can just go here, say add, right? So select a previous knowledge base. So I'll just select something, right? This might not even work. So, but you get the concept, right? And then you give instructions and tell it what knowledge base is. So now you have a Lambda backend action group. You have a knowledge base action group. And yeah, then your agent is all set to answer from both of these sources, right? One more and the final type of agent then you can create is a collaborative agent, right? So collaborative agent is where you have a one supervisor agent, and then there will be sub agents who will be reporting to that particular supervisor agent. So if you see here, I have created a use case where I want to make an episode of The Office famous TV show, right? In that case, I will have a supervisor agent here. And if you go in the agent builder, there will be three sub agents who will be reporting to this particular agent, sub supervisor agent. So my supervisor agent, I have provided it like detailed instructions here, like how you should come up with a episode script, right? I tell it like, well, first when you get it, figure out the plot based on the user theme, right? So if I give a theme of return to office, it first tries to make a plot out of it, then figure out who can be a good cast for that particular episode. Once you figure out who will be the cast, then associate dialogues to each cast member. And then what the supervisor agent does, it takes all of this and writes the whole episode for you. I will not run this, but I do have a screenshot because it will take time and we have one more presentation lined up. So once uh, I ran this agent at the back end, and you can see here that I said, okay, get me an episode about tech layoffs due to AI agents in workplaces. This is how the trace looked at the back end. The supervisor agent was here. So first it called the plot generator agent, then it called cast agent, then it called dialogue writer, and finally the formatting agent, right? And once all of this was done, it returned with a response of an episode, which was pretty cool, right? Here is the plot: the office AI apocalypse now. So this is second kind of agent. So one is like a standalone agent, and second is orchestration agent, like multi-collaborative kind of environment where there is a supervisor agent who orchestrates different tasks between all these sub agents.